Hey everyone, welcome back to the channel. Today I'm going to show you something that completely changed how I think about state management in Flutter. I'm talking about event component system architecture. Now, I know what you're thinking. Another state management solution? Really? But stick with me, because by the end of this video, you'll see why this is different. We're going to build a real example together, from scratch. And I'll show you the inspector tool that makes debugging actually enjoyable. Let's jump in. All right, first things first. Let's create a new Flutter project. And we need to add the package. Open your pubspec.yaml and under dependencies, let's add the library. Great. Now, instead of building the typical counter example, let's build something more interesting. A user profile feature with API calls. This will show you how ECS handles real-world async operations. But first, let me explain the three core concepts. In ECS, everything revolves around three concepts: components, events, and systems. Components are pure data holders. Think of them as your state containers, but they don't have any business logic. Events are triggers. They signal that something happened. Like user clicked the load button. But they don't contain logic either. And systems? That's where all your business logic lives. Systems react to events and update components. The magic is that these three things are completely separate. Data doesn't know about behavior. Behavior doesn't store data. And everything communicates through events. Let's start with components. Here is a component to hold our user data. It extends ECS component with a type parameter, which in this case is the user. It starts as null because we haven't loaded data yet. The build descriptor method? That's for the inspector. It'll show meaningful information in the logs instead of just a generic type name like user data component. Now, since we're doing async operations, we need a loading state component. Here is another component that holds user data loading state. This is a pattern you'll use constantly. The loading state has 4 states: idle, running, success, and error. Clean and predictable. Let me add one more component for errors. Perfect. 3 components: data, loading state, and errors. That's all the state we need. Now let's create events. Events are interesting because they don't take constructor parameters. Instead, we use a pattern where you trigger them with data. The event has a user ID property, but it's nullable. When you want to trigger it with data, you call trigger with user ID. After the system processes it, we clear the data. The build inspector method creates a custom widget for the inspector. We'll see this in action later. Trust me, it's really cool. Now, components and events are done. Let's build the system where the actual logic lives. The system will react to our load user event, call an API, and update all our components. First, reacts to tells the system which events it cares about. In this case, load user event. The interacts with set declares which components the system will read or modify. This is crucial for the inspector, which uses this to build the dependency graph. Now, reacts if is really clever. This getter determines whether the system should actually react. Here, we're saying don't react if we're already loading. This prevents duplicate API calls if someone spam clicks the button. In the react method, we extract the user ID from the event, update the loading state to running, clear any previous errors, and then start the async operation. Notice how we clear the event data right after extracting it. That keeps the event clean for the next trigger. The actual API call happens in the private load user async method. I'm simulating it with a delay here, but in a real app, this would be your HTTP call. On success, we update both the data component and the loading state. On error, we update the error component. Everything is explicit and traceable. Now let's wire this all up in a feature. A feature is just a container that groups related components, events, and systems. Everything gets added in the constructor. No dynamic additions at runtime. That's it. Everything is declared upfront. The architecture is explicit and visible. Now let's build the UI and hook it all up. First, we wrap everything with ECS scope and provide our user profile feature. This makes the ECS system available to the widget tree. Our page extends ECS widget instead of stateless widget. This gives us the ECS context parameter in the build method. Using ECS.watch, we subscribe to components. Whenever they change, the widget rebuilds. Using ECS.get, we just access the entity without subscribing. See how clean the button is? Just call trigger with user ID on the event. No block callbacks, no set state, no nothing. Just trigger the event. The rest is standard Flutter. We show loading, error, or data based on the state. Now, let me run this and show you something really cool. Okay, the app is running. You can see we have the initial state. Let me click the button. See that? Loading indicator appears immediately, then after 2 seconds, we get the user data. Name, email, everything updates automatically. But here's where it gets really powerful. Let me add the inspector to show you what's happening under the hood. I've added the inspector as half the screen, so we can see both at once. In a real app, you'd probably only show this in debug mode. On the right, we have the ECS inspector with 4 tabs. The first tab contains general info about the system. Overview tab shows cascade analysis, performance metrics, and system health. If you had circular dependencies, they'd show up here with warnings. You can also see the cascade flows, which are chain reactions in ECS system. In the Entities tab, you can see all our components in real time. Let me click the button again and watch what happens. Watch the user loading state component. It changed from idle to running. And now to success. See how the user data component shows our custom descriptor, user John Doe? That's the build descriptor method we defined. Now let me click on the Logs tab. Every system activation is logged here. You can see load user system reacted to load user event, the timestamp, the system name, everything. And look, we can filter by feature, by name, by log level. This is incredibly useful when you have multiple features running. Now the really cool part, the Graph tab. This is automatically generated from your code. See how load user event connects to load user system, and load user system connects to all 3 components? This graph updates in real time as you add systems and features. You can see your entire architecture at a glance. If you had cascade flows where one event triggers multiple systems that trigger more events, you'd see the entire chain visualized. This isn't documentation you have to maintain, it's a living representation of your running application. All automatically. So let me recap what we just built. We created 3 components to hold state: data, loading, and errors. We created an event to trigger the load operation. We created one system with all the business logic: validation, API call, error handling, state updates. We packaged everything in a feature. And the UI just watches components and triggers events. No block boilerplate, no provider context juggling, no set state management. Everything is separated, testable, and fully observable through the inspector. Now, this was a simple example, but imagine this scaled up. Multiple features, complex workflows, async operations everywhere. The pattern stays the same. The inspector shows you everything. In the next video, I'll show you advanced patterns, how to handle complex auth flows with multiple steps, error recovery with retry logic, cross-feature communication, and performance optimization. The package is available on GitHub right now. Link in the description. If you want to see more Flutter architecture content, hit subscribe. Drop a comment with your biggest state management pain point. I read every single one. Thanks for watching, and I'll see you in the next one.